Hello everyone, welcome to the HSPF training by DSI. This is Anurag Mishra and we are in the video HSPF420 reviewing the output generated by HSPEXP Plus for hydrologic calibration. In the previous video, we used HSPEXP Plus to generate the calibration output, that is the comparison of observed and simulated flow. That comparison was done on multiple ways and we will just look at that output quickly. Okay, so as I said earlier, HSPEXP Plus generates outputs in a folder called reports underscore, and this number refers to the date. So it was August 13, 7:05. That time HSPF model was run. Let's look at the output, and there are a lot of files here, so let's focus on some of the files that are most important, at least the way I look at it. So this is the expert system stats, which I talked about in the last video also. This compares the observed and simulated flow in various ways. So it looks at the highest flows in 10% high, 25% high, 50% high, then low, storm volume. Now these storm, if you remember in the EXS file, these storms were selected. So storm volume is based on that. Storm peaks, recession rates, how well we are doing in terms of volume in summers or winters, those kind of things. So when it does compare all of that, it calculates error rate, and with error rate there is some kind of default criteria that HSPEXP Plus has that can help you figure out whether the model is calibrated or not. Now when you are doing your own calibration, you have to take your own judgment for that. So when I start using this file, I first look at the evapotranspiration. If you remember, I said that the evapotranspiration values provided in the NLDAS data may not be accurate. So it says that for 2 years, our watershed saw 56 inches of potential evapotranspiration. And because of that 56 inches of potential evapotranspiration, what actual evapotranspiration that happened was 28 inches. So 56 inches is not possible from a watershed in Minnesota. It should be something around 32, 33 inches. And so what you have to do is you can look at the atlas. I'll put a weather atlas in a link in the description below, and you can look at that atlas and figure out the location to get an approximate idea. There may be other local studies that will give you a better idea of how much should be the evapotranspiration. So whatever method you are using, you may use Hammond, you may use potential Penman pan. That is what I used when we were working in this watershed. We used Penman pan. Even there was overestimation or underestimation, and we had to use multiplication factor in the UCI file. So this is the potential evapotranspiration. We had to use multiplication factor to reduce. So for example, in this case, it's probably over predicting by 80%. So we have to use a factor 0.4 or 0.5, something like that. So that will reduce the evapotranspiration, potential evapotranspiration. So that is always the first step when I'm doing the watershed hydrologic calibration. Then I also want to look at what is the rainfall that is applied to that watershed. Is that reasonable or not? And so that is not in this export stats. So let's look at other file. This is annual flow stats. So this is only 2 years of data, so it's not very useful for hydrologic calibration, but just let's look at it quickly. Moisture supply is 32 mean moisture supply is 36 inches. That seems accurate based on my observation there, but you will have to talk to the watershed manager to figure out if this one is accurate. So these are the two main input that we want to see before we even go further comparing the observed and simulated data. In general, once we have more accurate estimation of ET and more accurate estimation of rainfall, and with the parameter sets that the initial parameter sets what I provided, you are generally in the same ballpark in terms of the observed total runoff, total runoff comparison. Now there are other things to look at. So we looked at export system stats, we looked at annual stats, that's a comparison of every year. So this is daily, monthly. This is, I get to it at a later stage once I figure out that I am doing a decent calibration. So I first go through these hydrographs, and these are very telling. They can tell me a very good deal. For example, in this one, if you see this flow is happening 4000 CFS in spring. So if it also produces graphs for each year, you can look at it. See, our simulation started in January and we immediately had such low flows. It's possible that the season before there was snow, and the amount of snow available, I was not simulating snow. So absence of snow in this model is the main reason, and that would change the state variable, change the snow depth available at the start of this, and that might change the whole calibration. So that thing is important. Looking at each one of these graphs, and then I just go through these graphs, and this is also the flow at log scale. So HSPEXP Plus will produce graph for each year at normal scale and regular scale, and it produces more data than you need, but you can decide what you want to keep and what you want to delete. Okay, so we'll just go through. These are the components, and you get to these components when you are at later stage. And so frequency duration curve is the next one that I look at. That quickly shows me that I am doing very bad in the low flow curve, and a lot of these things in this case will be fixed when the evapotranspiration is fixed and when I start simulating snow. So these are once I have these major things figured out, then I start looking at monthly average, how I am doing it in each month. Here you can see that in January and December I'm doing, all the winters I'm doing very bad. I'm doing bad overall, but again, so this is one of the numbers I look at. Now there are other numbers, for example, potential evapotranspiration. These numbers may not mean much if you do not know the actual value of that, but this can help you figure out if there is any issue with the trend or something like that. So I remember in one of the watersheds what I did was that I changed something, and December there was excess evapotranspiration that was causing the model calibration issues. So there is a lot more information here than what you need, and there should be an advice document here. Yes, there's an advice document here that can help you figure out some of those things, and this also says first look at the observed data and see if the data is accurate or not. It also produces a folder called storms, where all of these storms that are listed in the EXS file, those storms are plotted in log scale and normal scale, and in general these are like daily plots, so they may not be of much value, but if you have the observed data at a higher frequency, at hourly data, then you can make sure that your model produces data at hourly output too, and then you can get more then you can get hourly storms here. So HSPEXP Plus will understand if you have all the data, and that's it. So once you get this, you get this information. Based on that, you go and change some parameters. Then you run again, and so for example, I just go and change all this evapotranspiration parameters. So I'm changing it to, I want to make it 33 inches or something like that, and then it is 55 inches right now. It is about 56 inches right now. So I'll use a multiplication factor of 0.6. And what I'll do is I'll do quick change, replace, this will be replaced by so I use the same multiplication factor for all the PEVT data, and I go ahead and run HSPEXP Plus again. Run model, hydrologic calibration, start. So looks like the run didn't complete. Let me just investigate the error. And okay, so when I clicked on OK, it opened the echo file by default in the VS Code. So if you remember, I talked about commencing execution. So the model was fine until this point. It read the model details fine, and then it said that on this specific date, on this reach, there was some issue in the F table. So the volume is too low, and in the last two row it was trying to do some interpolation. And if you look at that same date, same reach, it's having problem 20 hours, and it's trying to do calculation, then it goes to next hour. So looks like on that day a storm occurred, and there was so much volume in that reach that HSPF run could not complete. So this is also a good demonstration of the errors that may come. So earlier we were under simulating, so there was not so much of a problem here, but now we are our model is simulating more flow, so we have this problem. Let's find that F table. So with F table it says that okay, this volume that we have set 27.04 is not enough, it might be having more flow. So it's already a ridiculous volume of flow, 27 acre feet. But let's for this purposes, let's make it 10 times 20, 270, and 55,000. So we are saying that no matter how much volume of water it is, it would be able to flow. Okay, so let's look at it. Let's run it again. Run model. Okay, so looks like the model is complete. Output is written here. Let's look at it again. And just so you know, if you look at echo file, it did not have so much problem in 49 reach. Now it's having problem in 54th reach, which is almost the output, the outlet reach. And so HSPF tries to run the model, but so since last time there were too many errors, so that's why it quit. This time it did not have too many errors, so it just continued. But you should always look at these things to fix it. Okay, let's look at this quickly. You can look at export stats for change. Okay, so our ET reduced 33, actually is 24, so that means there's a almost 4 inches reduction in the ET, and total volume error minus 68. What was it before? It was minus 68, now it's minus 46. So that error has gone down. Then we have to look at snow simulation and initial condition. So that's beyond the scope of this this course. But I hope you understand after the end of this exercise that what outputs are generated, how to look at those outputs, and what outputs are more important. And the next video we'll talk about the water balance and how to generate water balance and how to look at water balance so that you can use it in the hydrologic calibration. So that's it for me for this video. See you in the next one. Thank you.